All right, and we're back again. So what I've done is I created the gripper fingers, pair gripper fingers for a single pin, and that's all done. We got the fasteners in there. You know, we changed the material, the color, all that good stuff, and now we want to move on to the drawing stages. So we'll do two drawings. We'll do a detail drawing of the gripper fingers. And then we'll do an assembly drawing, which will include the fasteners, the shank body, and the gripper fingers. It will not include the pin. Okay, the pin isn't necessary at this point. All right, or for the assembly. So let's move on to the drawing. Now the fingers are identical, left and right. So we're only going to have one drawing. You're the same unless you make the left finger and the right finger different. You're going to have one drawing of one of the fingers, and that's what I'm going to do here. So we'll go to design and drawing, and from design, and then we're not going to do the full assembly, so I'll click off that, and I'm going to select the components, and I'm just going to pick the left finger. It doesn't matter, you know, which one you pick. We're going to do an ASME standard millimeter, and we'll do a B-size drawing sheet. And we'll say OK. All right, and here it goes. Okay, so the first thing to get this set up, you kind of need to know how you're going to orient what your base view is going to be. And here we can kind of play around with it. You know, since I haven't done this yet, I'm going to be playing around a little bit too. But I don't think that's a good front view or base view. The base view does, by the way, the base view does not have to be the front view, but that's kind of how my brain works. So I'm going to switch this to the left view, and we'll view like that. And I think that may be better for me. Again, remember, we can kind of fix things as we go. So this isn't carved in stone. And I think that's good. Let's see what happens if we go to a scale of 2 to 1 too, because that looks a little bit small. I wonder if we can get our dimensions in there. I bet we can. So I'm going to go with this one. So I'm going to go here for my base view. I'll say OK. Groovy. And now I'm going to do my projected views, and I want a left view. I also need a top view. Or actually, you know what? I think a bottom view may be more useful. And I think I want also to do a inside view like that. Yeah, because so this one. All right, so now let's take a peek at these. Okay, first thing I'm going to say is some of these hidden lines are confusing. They're but you know, I think we can work through that. We can always decide to leave off the hidden lines, but kind of the general rule of thumb is if you leave off the hidden lines, they need to be removed from an entire view. So I'm thinking these hidden lines are not very useful. But I think I'm going to just leave them in there anyway, because I think that it would be, taking them out would be not exactly helpful either. So let me go ahead and get some of the center marks in there. This is a good thing to bring in right there. Right there, that one didn't come in big. We'll do that right there. And then that, again, that didn't come in very big. So now let's do center line. We'll go from here to here. That looks good. We'll go from here to here. And that's kind of right on that edge right there, but it's just going to have to be, and actually I'm going to lengthen a little here to make a clear distinction for what that is. And then that's good. Now one last thing, because I'm going to take advantage of the symmetry of this, the natural symmetry, I'm going to take this one and I'm going to expand it right to there. Right? That's going to possibly help me with some of the dimensioning. So we'll do that there. And that basically says, hey, this feature is, this thing that I'm designing is symmetrical. And I can take advantage of that in the dimensioning part. Okay. So, so let's get the basic shape down first. So we'll get the overall width right there. We'll get the overall height. And let me make sure I get the right edges. With all these chamfers, it's, yeah, see, look at that. I got the wrong edge right there. I don't want to get that. This is a good little thing. So 4715, that's kind of an odd distance. You know, I might go back and change that, you know, if I was doing this again. The total distance here, get the total height from here to here. There we go, 52.9. Again, a little odd. The width across here. So I'm kind of working in stages. I'm getting the overall size first. Okay. Right. I think that pretty much covers that overall size, right? Everything else, because of symmetry, I don't need to go 8 from here to here, or I don't need to go 11 from here to here, right? Symmetry says, hey, if the dimension spans across it, then the distance from here to here is exactly half of the 22. So that's where symmetry really helps. I think that pretty much covers that. Now I do need a thickness dimension, and I don't like this view for that. I like this one a little bit better. I think it's a little bit more explanatory. So we'll put this down here, and then we'll go up here with this one. Right. Okay. And that's it for the overall shape. Now let's get the flaps, right? So what I want to specify is how much these extend. So I'm going to dimension from here to here, and those are 2 millimeter extensions. Go right there. Yeah, I shouldn't have grabbed that edge. I should have grabbed it right there. Okay. And then the inset right there, I want to do that also, and so that's going to be from there to there, 16 again. Now is that's really that right there, but it's, yeah, so that's a redundant dimension, but I'm going to leave. I'm going to take that out because we don't need that. Or in fact, maybe I can do this. Here's a little thing. We can make this a reference dimension. Right? A reference dimension doesn't get added to as a redundant dimension. So we can go right there. All right, and that's it. Now we want to dimension the hole. Right, so that's a diameter dimension, and I'll whoops. Oh, come on. There we go. And it's not a diameter 4. Don't forget to, this is actually a M4 by 0.7 fastener. All right, so that has to be dimensioned appropriately. It's clearly going all the way through. All right, so now the only other thing left to do is to deal with this cutout right here. And since I'm going to have a note for the chamfer, I'm not going to dimension both of these. I'm just going to dimension the main spherical shape right there. So now this is not something that we covered in class because it's kind of a a unique thing, or you don't run across it that much. So this is going to be made from a spherical radius or diameter. Since this is not a complete sphere, I'm going to use spherical radius, okay? And I'm going to dimension the inside. Whoops, come on. There we go. Dimension the inside, and we'll pull it out right there. And we're going to make the note, we're going to add an S in front of that. All right. That's going to make it, you'll see, a spherical radius. So that's the symbol for spherical radius, right? And we're getting that in there. The extra line here is derived from the chamfer, okay? This we're going to dimension as a diameter, but we're going to dimension, whoops, I'm sorry. We need a linear dimension, but we're going to put a diameter symbol. So I'm going to go from here to here, right? And then we'll put that in there and do a symbol. There we go. Okay. So 9.89. And then we need to give a thickness from here to here. Okay. And then we go right there. Okay, so those are kind of the size dimensions. All right, that's pretty much all we need. Now we need some location dimensions. We need to locate where this is. So let's go to a linear dimension, and I'll pull it off of here, and that's 8. Okay, and then we need to locate this one. This is going to be, this might be the same as that, but yeah, it's a little bit different. Okay, so that's good. And now I'm going to spread these out a little bit. Everything looks pretty good. Spacing wise, so we have location. Notice that this lines of symmetry really help with cutting down the dimensions. We don't have to locate a lot of features because they're on the center line. And I think that's it. Okay. Now, we do need to add the notes here. So I'm going to go to text, and we'll put it right in here. I might need to move some things, but we'll go here. And let's just do that. And so this is in your standard notes, unless otherwise specified. All dimensions in millimeters. And now I'm going to pull up my the notes that I kind of have for. These are on your. These are in your module. I'll show you. This is the standard. All right, so I already gave you these notes, so you can couple of those. There's one on the last, say, drawing in accordance with ASME. Okay, so we'll go, whoops, actually this is going to be 1, 2, drawing in accordance with ASME, Y 14.5-2009. I'm going to run out of room here. All fillets and rounds R1, right? Maybe we made those all R1. And for all chamfers, 0.5 by 45 degrees. Right? And oh, we got one more that we got to put in there. So I think I'm gonna have to move these a little bit. Let's move this up a little bit right there. And we'll move this, whoops, we'll move this up a little bit right there. There we go. That gives me a little bit more room. And we'll move this up like so. And then we can go 5. What am I missing? All threads in accordance with ASME B 1.13M-2001. That's for metric threads. So there's nothing else really that I need to do. We're not doing anything with tolerances. There's no surface texture. I suppose if I wanted to be real complete, I could say remove all burrs and sharp edges. That's kind of overkill. There we go. All right, so that's it. That's done. All right. Very straightforward. All right, let's save that. And next we will tackle the assembly drawing.